In this video, we're going to go over one of my all-time favorite algebra problems, factoring what is called the difference of two squares. Let's dive right into it. So the reason why this is called the difference of two squares is this is a square, x squared, and 16 is a square of 4. And there's a difference, minus. So it's a difference of two squares. So how do we factor this? I basically teach students to not memorize this, but do it like you've factored before. So if you haven't yet learned how to factor and watch the previous videos on this, please watch that first, otherwise this is going to be really weird. But if you have watched those videos, well, you're ready, let's roll. So how do we do this? Well, the way that I look at it is, I look at it as x squared, and then there's no x term. So write it as plus or minus, doesn't matter, 0x. minus 16. You won't have to do this step after doing a few of these problems. You'll see a pattern. But this explains what's going on. So we have a 0 as a coefficient because there's no x term, so there must have been multiplied by 0 to get rid of x, right? So if we're factoring that, now this becomes a straightforward factoring problem. Now we're saying that we have x and x, and we're asking ourselves, what factors of 16 combine to give us 0? Well, if we look at the factors of 16, that would be 1 and 16, 2 and 8, 3 doesn't go into 16, but 4 does, and then 8 and 2, 16 and 1 are reversals, so we stop our factor list. Now of these, the only pair of factors that can combine to give us 0 is if the numbers are the same. We'd have to have a -4 and a +4. Right? 2 and 8 can't cancel each other out, nor 1 and 16. Because you're looking at what numbers multiply to -16 that add to 0. That would be -4 and 4. Isn't that beautiful? I think that's so cool. And so to check our answer, so this is our answer, but to check it, FOIL. X times x is x squared. Outer is x times 4 is 4x. Inner is minus 4x. Last is minus 16. And so we have x squared. 4x and minus 4x is 0. Minus 16. It checks out. It's beautiful. Check those answers by foiling. Let's do one more example, then I think you've got it. And then on the other side of this video, I've got some bonus content where we're going to go over how to factor when there's two variables involved. Ooh, you'll be fine with it. Okay, r squared minus 144. Again, if you need to, visualize it as r squared plus 0r minus 144. So this turns it into a straight up normal factoring problem. We've got r and r, and then what numbers multiply to give us 144 that combine to give us 0? They'd have to be the same number because the only way to cancel out and get 0 is if we're adding and subtracting, right? Or adding a negative of the same number. So 12, when added to -12, would give us 0 and multiply to give us minus 144. That's it. The difference of two squares explained. Again, other side of the video, two variables with factoring. It's a challenge that some of you might have in your math classes, and if you do, stay tuned for that. If you don't, it's been fun. And here we are on the flip side of the video where we are going to, as promised, learn how to factor trinomials where, oh my goodness, we have two variables? How do we do that? Well, you actually ignore one of the variables. So I look at this and I literally treat it like t squared minus 5t plus 6. And you might be like, well, why can you just do that? Let me show you. So what I have here is two parentheses, going to factor like normal, so we have t and t, and we need factors that multiply to 6 that combine to give us -5. Well, what multiplies to 6? 1 and 6, and then we've got to be careful with this, 1 and 6, and 2 and 3. Both can combine to give us -5, right? If these are both negative, we'd get -5, and if this is negative, -6, we get -5. We know it's -2 and -3 because they'd multiply to give us +6. If this was negative, they'd multiply to give us -6. So it's -2 and -3. And you might be like, well, but that's not going to multiply to give us back anything with an m in it. No, it won't. So we'll put the m's right here. That's it. That's how you deal with this problem. And you might say, well, why does that work? Well, because t times t is t squared, t times minus 3m is minus 3mt, minus 2mt is what you get here, that's going to be minus 5mt. Minus 2 times minus 3 is plus 6, m times m is m squared. So that second variable is there just to confuse a little bit, but it's no different than factoring like normal. We'll do two more. Okay, so here we've got x's and y's. So how do we deal with that? Well, again, pretend like the y's aren't there. You have x and x. We know that we need numbers that multiply to 16 that add to 8. Well, 1 and 16 won't do that, and 2 and 8 won't add to 8. 4 and 4 will, so I have plus 4 and plus 4. But there's some way that we need to get a y squared, and the only way to get that is if there's a y on each of these, so that we get xy terms. And when you distribute this out, we'll do the check here actually. So this is our answer, we'll check. X times x is x squared. X times 4y is 4xy. 4y times x, I'm gonna make that 4xy so the like terms are a little more clear to us. And then 4y times 4y gives us the 16y squared. When you combine those two terms, you get 8xy, 16y squared, x squared. Not bad. One more. So again, ignore it. I'm looking at this as g squared minus 11g plus 60. That's how I'm looking at this problem. Now, how in the world do I deal with that? Well, not too bad. And actually, I'm going to make that minus 60. So this works out real nicely. Okay, so change the problem to minus 60. Now we factor like normal. This is what's going on in my head right here. I get g and g. The factors of 60 that combine to give us 11, not 1 and 60, 2 and 30, no. 3 and 20, no, but getting closer. 4 and 15, they're 11 apart. If I have negative 15 and positive 4, they will add to give me negative 11 and multiply to give me negative 60, but I still need the e there. So I put in a little e here and here, and now when I multiply these two, I get negative 60 e squared, and I'll get the negative 11 e that I so desire times g. Nice. So moral of the story is you get two variables, it's not so bad. Pretend like that second variable's not there, and rock and roll and then add it in the end. See you next time.